Greetings, everyone. Thank you for joining us at Exchanging Ideas 57 Global 5G Evolution. I'm Kaneshwaran Goindasamy, the founder of Global 5G Evolution. A warm welcome to great speakers all around the globe. And to the audience there, please do click the subscribe button on our YouTube channel. Um, Today, at the end of this session, we will have two uh, proposed questions. One is, what are the top trends in the telecom sector for 2025? And number two, telcos behind the AI curve. I think this will be an interesting debate that the audience will be fascinated with the feedback from the speakers. Today, I will be presenting on the topic of 5G advanced monetizing the telco to TECO transition. And if we see from this slide that um, at the center, the connectivity, 5G Advanced significantly enhances the network as a service by providing more flexible and programmable networks through SDN and NFV, refined network slicing and tailored connectivity, standardized APIs for automated management, and seamless integration with cloud edge computing. And this allows businesses to dynamically provision and manage network resources as needed, subscribing to specific network slicers for optimal performance, security, and latency. 5G Advanced will expand support for massive IoT deployments, enabling connectivity for a wide range of IoT devices and modules, crucial for various B2B applications. For communication segment, 5G Advanced will enhance the URLLC, crucial for time-sensitive B2B applications like industrial automation, remote surgery, and autonomous vehicles. For the services segment, managed networks can leverage 5G Advanced, improve network automation and orchestration. System integration becomes more sophisticated with enhanced API capabilities, and managed security benefits from improved the network security features as well. Service orchestration can be more dynamic with improved network programmability as well. Now, from this slide, 5G Advanced supports the evolution of telco models by providing enhanced flexibility and efficiency across the spectrum. For integrated operators in the A segment, it enables a wide range of services and tailored offerings through features like network slicing. For the B segment, the light MVNOs, it covers the barrier to entry with flexible network access and differentiated services. Full MVNOs and asset-light operators, the C segment, benefit from more efficient core network management via NFV and cloud-native architectures. Crucially, 5G Advanced facilitate neutral host models, the D and the E segment, through efficient and infrastructure sharing and robust security, enabling operators to share the infrastructure while maintaining control over their services. This fosters a more diverse and dynamic ecosystem, empowering both traditional players and new entrants as well. Now, this is interesting where 5G Advanced directly supports customer centricity, as you can see in the center, expanding the digital service portfolio by delivering enhanced experience through faster speed, lower latency, and greater reliability. 5G Advanced is crucial for achieving a defragmented network architecture, as you can see in the pink, moving away from monolithic designs towards a modular, flexible system through enhanced SDN and FE, a service-based architecture, which is known as a cloud-native architecture, edge computing, integration, and advanced automation. Um, Large mobile network operators like NTT Docomo, SK Telecom, Vodafone, DT, Telefonica, AT&T, Dish Networks were among the early movers exploring the defragmented architectures. But widespread was not yet at the moment, right? So it's more evolutionary than revolutionary, and I think 2025 we can see more moving into this segment. Now, from this part, 5G Advanced empowers all TECO archetypes by providing a robust and flexible network foundation. For dominant TECOs, which is the A segment, it reinforces the leadership through cutting-edge applications like AR, VR, metaverse, differentiated offerings via network slicing. Service techos in the B segment benefit from enhanced service offering and improved delivery through tailored solutions and predictable performance. And the network techos in 6C segment are enabled to offer network services as a service, the NAS, and infrastructure as a service, providing customers customized network slicers and specialize the 5G infrastructure. Now, this is quite interesting from 5G advanced point of view, a robust foundation for service techos to excel in both horizontal B1 and vertical the B2 by significantly enhancing the customer experience through higher speed, lower latency, and improved reliability, directly supporting the digital customer experience platform and customer experience. For horizontal solutions, 5G Advanced ensures seamless connectivity, cross-device, and personalized experience through network slicing, supporting single stack product catalog and billing. In vertical solutions, 5G Advanced enables a tailored industry-specific offerings like massive IoT for B2B, robust cybersecurity solutions, and seamless cloud integration aligning with IoT, cybersecurity, and cloud services as well. The other prominent is the API-driven architecture of 5G Advanced, further facilitate the third-party service integration, enhancing the comprehensive vertical solutions. So cloud native design aligns with cloud native network while it supports for the AI, ML, and automation, operation or optimization as well. And also enabling strategies like a dynamic pricing and next best action as well. Now, this is 5G advanced network slicing capabilities, which is crucial for network as a service, allowing the creation of customized network slicers with tailored performance, aligning with network slicing with real resource orchestration and supporting the necessary API-driven architectures. For IaaS, the 5G advanced supports specialized infrastructure technology such as dedicated or private 5G networks directly addressing the IaaS concept. This also creates wholesale opportunities for network techos to lease network capacity, reflecting the wholesale segment towards the MVNOs. Also, the promotion of API-driven architecture fosters integration with third-party services, expanding the service offerings and driving the innovation as well. Now, 5G Advanced supports insight-driven strategies through real-time data collection from the connected devices, fosters innovative products and services via enhanced capabilities like URLLC and MMTC, and improves the customer experience with faster speed and lower latency. 5G Advanced empowers the workforce with access to real-time information and collaborative tools, supports digital-enabled technology architectures by integrating the cloud, edge, AI, and IoT, and foster integrated partner and alliance ecosystem through seamless connectivity and data sharing. And lastly, 5G Advanced supports both service and network techos, but has a more pronouncement impact on the latter due to its direct enhancements to network infrastructure and capabilities. While both benefit for improved customer experiences, seamless interactions, and empowered workforces, 5G Advanced significantly empowers network techos in insight-driven strategies through network data analysis, digitally enable architectures by facilitating the cloud and edge computing, and responsive operations by optimizing the network performance and monitoring. So both archetypes benefit from innovative products and services, an integrated partner of ecosystem enabled for 5G Advanced with the core strength of network techos in the network infrastructure, positioning them to leverage these advancements more effectively, resulting in a general high impact across the most core capabilities. So I think this is overall my presentation, and let me stop sharing this, and let me introduce our next speaker, Georgia Cook from London, UK, to present on AI in 5G security. Over to you.
Thank you. I'll just share my screen. Got that?
Yes.
Fab. Okay, so um, of course, we can't really move in tech at the moment without talking about AI. Um, I'm here to talk a little bit about the best way to implement it, how to avoid telcos rushing in and ending up like bulls in a china shop. Um, my name's Georgia Cook. I sort of specialize in security for telcos at ABI Research. And today I am going to break down, if my slides will work, the why, the where, and the how of AI specifically for security in 5G networks. So starting with the why, I may be preaching to the choir, but uh, networks are increasingly complex. Traffic volume is exponentially growing. There are massive shortages, particularly in security staffing, and we're up against AI-enabled attacks. So in that sense, we find ourselves having to fight fire with fire and integrating AI into our security strategy. So looking at exponential data growth, it's just becoming too complex to manage these kind of networks without some automation. The skills shortage for any security opening across all verticals, it's very difficult to staff, but this is particularly true for cellular networks where you're up against not having enough 5G experts and needing that dual specialty of security and cellular expertise. Half of the 5G security openings on LinkedIn were posted with under 10 applicants at the time of writing the slides. Um, there just isn't enough staff to fill the need. And when it comes to AI-enabled attacks, there's a myriad of ways that the people we're up against are using AI already. There's automated vulnerability hunting. There's the fact that fraud is becoming much easier to implement to a more sophisticated degree. Thanks to large language models overcoming language barriers, it's much easier to write a convincing fraud campaign. And finally, even more convincing, there are deepfake audio and visual options so that you can start to get into really sophisticated attacks with very convincing video involved. So all of that is sort of the jumping off point. We're at a stage where we're going to have to implement AI into our security strategy somehow. The question is where? If you're familiar with the NIST 5-pillar model that is used throughout security, it's the 5 pillars that we use to sort of describe the security stack. And there's a point in each of those layers for AI for 5G networks. The first stage within the model is identify. As I talked about, the networks are more complex, higher traffic. Often with telcos, you're dealing with networks that have been merged and dealing with legacy networks. So replicating the attacker's AI-enabled vulnerability hunting uh, lets you see what they see. You can start to pick through those complex networks. As the protect stage, this is kind of what everyone thinks about when you think of security. It's starting to install tools. Um, in those complex networks, installing tools is easier said than done. And quite a lot of open security threats are a result of misconfiguration. So automating tools to ensure that this protection stage is done correctly is really important. Finally, there's detect. Um, this is that ongoing need to flag a threat, essentially. But as AI-enabled attacks are becoming more prevalent, these are evolving faster than ever. It's no longer a case of being able to have a list of known problems and look out for them. You need flexible and adaptive threat detection. So you need a detection even of novel threats that you may not have ever seen before. And that's where you get into anomaly detection and, again, using AI. There's respond. This is the stage, of course, where you flag the threat. You know there's a problem. You need to decide what you're going to do with it. This is where that skill shortage comes in. If you don't have enough security experts to respond, This is the really tricky stage. You're dealing with people that maybe aren't familiar, particularly with 5G security and how those attacks look, how they're going to im- impact the network, and essentially what you need to do, how you're going to quarantine that problem. However, with AI, with particularly large language model based solutions, you can summarize the problem even to more entry level staff that maybe wouldn't be able to unpick what's being flagged by themselves without that additional support. The final stage of the model is the recover stage. This is getting back to business as usual. And particularly in an increasingly legislated telco environment, what's really important is that large language model based summary. It can now be fed into a report. It can help you meet your compliance needs by essentially covering what's just happened and immediately post threat, which is particularly important in those environments where you have a certain amount of time to file a report. Uh, you already know what's happened. You don't have to do all that analysis trying to unpick it, and it feeds straight into your compliance. So that's where we're putting it in. This is how you do it properly. This is where I'm going to advocate a little bit of caution. It can be tempting, as I said, to crash straight in. Um, the reason it's tempting to crash straight in is that there are natural alignments. There are all these promises that AI can make us in terms of rescuing us from these problems. First problem, there's more data, the networks are more complex. Easy. AI processes it, summarizes network traffic, helps us digest what we're looking at. The skill shortage I talked about, AI frees up the time of expert staff so that they can more effectively guide the overall security team, and entry level staff can take on the more menial work with the support of AI tools. You can tailor the response. So telcos typically, particularly high tier telcos, have a wealth of network data that you can train models on, and it means that the response is specifically tailored within the network. This is particularly important given the risks of just porting IT security tools, which is often a strategy used, but it doesn't quite work. You're never going to fully capture cellular security threats with an IT based tool. So, by allowing AI to tailor the solution, you help overcome that. Finally, time to respond. As I mentioned, these issues compound into making security incidents quite difficult and quite time costly to deal with. AI expedites all of it, and we know that that makes attacks far less impactful. They cost less. They uh, have less of an impact on the network. So it all sounds very promising. However, as I said, I'm advocating caution. So, how do we do this properly so that we aren't just introducing another threat vector? First of all, models have to be explainable, particularly in the cellular world. Neural networks are traditionally something of a black box, and as a telco, you simply can't have something like that on your network, particularly making operational decisions. You need your AI models to, through some method, explain to you how they got to the conclusion they got to. Um, Often the technique is to use neural networks to make the decision and then have a secondary model that regresses the decision and explains to you how they got there. So there are approaches to take. It's all manageable. It's just something that has to be implemented in your policy. Next is human in the loop. I spoke about freeing up the time of those security experts. They should really be guiding this. And you need to, particularly in the early stages, not have AI run away with itself. Making sure that there's a human in the loop checking decisions, particularly in the training stage, helps you get to a really refined solution. It's all based around a controlled rollout with ongoing protection. I mentioned policies earlier, they're essential. Um, Already quite a lot of tech companies broadly, but also cellular networks, um, are tempted to rush into implementing these tools without full policy backing it up, that's how you run into problems. So all of this has to be implemented thoughtfully and with an overarching strategy. And finally, making sure things are tailored. So making sure that you do train on your data, making sure that you do tailor the solutions to your specific needs and not getting kind of caught up in the hype. So those are my recommendations. Overall, I think AI certainly does have a wealth of opportunities to offer 5G networks broadly, but particularly within security. But it has to be approached with a degree of caution with an overarching strategy. Thank you. I'll hand over to the next speaker.
That was brilliant. Thank you, Georgia. I really appreciate that.
Thank you.
Let me introduce our next speaker, Dr. Xinyi Tu from Helsinki, Finland, to present Industry 5.0 and Industrial Metaverse.
Yeah, hello everyone. It's an absolute pleasure for me to speak at the Global 5G Evolution Conference, Exchanging Ideas session. So today I will be taking you on a journey through my work on the industrial metaverse, a concept that merges physical and digital world within the context of the Industry 5.0 revolution, which is an era that humans and technologies work together more closely than ever before. So before we dive into the core of the presentation, I'd like to briefly introduce myself. My name is Xinyi Tu, also known as Joyce, and I have been fortunate enough to work in various roles that center around advancing Industry 5.0, AI, and industrial metaverse technologies. In my current role, I'm a postdoc researcher at Digital Lab, Aalto University, in Finland, and also a visiting scholar at Cyberhuman Lab of University of Cambridge, UK. I'm also on the scientific advisory board of the Meta Ethics Institute, and I also work as a senior AI and operations consultant with PwC Finland Advisory. I'm deeply involved in multiple international initiatives related to Metaverse and Industry 5.0. Some of these include the European Commission's Forgen Expert Forum and the Metaverse Standard Forum. I'm also a mentor at Human in AI and Tech in Finland, fostering the inclusion of the tech community. So that's about me. Let's dive into the topic. First up, a quick historical lesson about our industry evolution. So unlike the previous industrial revolution, which technology-driven, Industry 5.0 is about bringing human back into the loop. So at the heart of the Industry 5.0 lies first this human-centric approach, which values human creativity, capability, ethics, well-being, and human satisfaction, and also emphasize upskilling and reskilling of the workforce. It seeks to leverage technologies to augment human skills rather than replace them. And then Industry 5.0 is also featured by this technology synergy. So this is enabled by open data sharing and also collaborative and interoperable platform approach. Then also the sustainability and resilience at the core, which emphasize reducing waste and energy consumption, while also preparing the system to adapt and recover from disruption. Then we have the shift from mass production to personalization and customization, which means industries can offer products that tailor to individual preferences and also meet consumer expectations. Last but not least, Industry 5.0 also promotes this collaborative ecosystem where different stakeholders work together along the value chain, including business, government, and research institute. Yeah, then what about metaverse? So the metaverse can play a critical role in Industry 5.0 by bringing the immersive digital landscape to enrich this human experience. So what exactly is the metaverse? So first, many people view it as a next era of internet, except it's not like flat screen, but a three-dimensional immersive experience where you can explore and interact with. Secondly, the metaverse is also about user-centric design. is a place where digital and physical worlds blend, enhancing how we experience the reality. Then the metaverse is also stand out because it's immersive and synchronous, meaning that the physical and digital world can coexist in real time. Lastly, the metaverse is really a convergence of various technologies driven by this platform and ecosystem approach. Here we are looking at the three key areas where metaverse is making an impact. First is the consumer metaverse. This is where most people are familiar with. So the focus here is primarily on enhancing consumer experience through virtual and augmented reality. Then we also have the enterprise metaverse. This is where businesses leverage digital environment to create more engaging and efficient workspaces. And finally, we have this industrial metaverse, which is also my research focus, where the metaverse technologies are applied in industry sectors. So for example, manufacturing companies, we can create the digital version of the factory to monitor operation and predict disruptions. And then in healthcare industry, metaverse can enable remote surgeries and training in a simulated 3D environment. And here I would also like to talk about how the vision of Industry 5.0 aligned with the industry metaverse aligned with the Industry 5.0 and ESG goals. So first, environmentally, it promotes energy efficiency, reduce waste, and minimize the needs for travel, which cuts
Dr. Joyce,
down the carbon emissions. Yeah. Can you hear me?
Yeah, yes,
Can you hear me still?
Yes.
I was, yeah, then come back. Maybe the network cut off for a while. Yeah, so I was talking about the ESG goals. So then talking about societally, the metaverse can enhance workplace safety and inclusion through virtual training and better data visualization. So the example here is Ford, for example, they saw the 70% of reduction in injury after implementing the VR training. Then on the governance side, the real-time data forming the supply chain digital twins, which enhance the transparency and accountability. So here there was an industry example where IBM's blockchain-based food trust system, which used by Walmart, reduced the trace time from 6 days to 2.2 seconds. As we journey into the metaverse, it's crucial to be aware of the challenges ahead. So as listed in our recent PwC survey, the top risks and barriers business leaders worry about include the cybersecurity, privacy risks, technology constraints, regulatory uncertainty, and also the intellectual property concerns. So to tackle these challenges, I have been proposing this comprehensive architecture for the industrial metaverse. So as you can see from the illustration, this architecture consists of the physical space and the metaverse space. So the physical space consists of the tangible aspect of a factory, such as machines, materials, personnel, and environment. Then we have also the underlying infrastructure, such as sensors, actuators, network, and supporting systems. So the network, for example, all the 5G related networking technologies play a big role here. And then on the right side, we have the metaverse space. So we have the coupling, which facilitates data exchange between physical and metaverse space. We then have data storage, which maintain the integrity of data. Then on the bottom side, we also have the semantic link, which is provide this knowledge synchronization through semantic models. Then on the right side, we have the extra interface, which consists of customization, communication, visualization, control, and also this spatial registration or synchronization model. So the idea is kind of the metaverse space also adapted to the physical environment. For example, according to the personnel's expertise, you can see the different context-aware information. Then in the middle, we have also important support functions such as identifier, security, simulation model, computation, analysis, and AI. Yeah, that's in a nutshell. Then to validate the architecture, my study also include a case study on this in-plant material flow tracking. So the physical space are located in our Aalto University's Industrial Internet Campus. So the idea is to kind of realize certain models from the previous proposed architecture in this environment, and like implement some models from the metaverse and physical space. So this case study shows that proposed architecture's potential aspect for creating robust, interconnected, and scalable industrial metaverse. Where on the right side, you can see that we also have this VR training solution for the crane operation, and also the augmented like on-site operation scenarios. Lastly, let's explore a bit some of our exciting co-innovation projects where our academia and industries coverage converge to push the boundary between of the industrial metaverse. So first, we have this machine eye project focused on creating knowledge-based service and digital operations for machines, integrating digital twins and human-machine interface to enhance operational efficiency and innovation. And next, we have Necoverse, where the goal is to harness industrial metaverse in shipbuilding, providing a platform for training, design, operation, and enhancing the industrial capabilities through advanced simulation and virtual environment. And lastly, we have this twin floor project. So it's about defining a fair data economy and creating an integrated IT and operational technology model. So it aims to improve intralogistics in production environment, making them more efficient and adaptable to current technology needs. So in wrapping up today's discussion, let's revisit our key takeaways. So first, Industry 5.0 extends the technology focus of Industry 4.0, which emphasizing enhancement not just in production, but also benefits to individuals, society, and environment. Then we have the second point is the industrial metaverse, which provides enhanced interactive experience that are crucial for modern industrial systems, supporting broader environmental, societal, and governance goals. Last but not least, building a scalable metaverse ecosystem should begin with well-defined, small-scale strategic use case, and this use case should be firmly rooted in a robust architecture framework. So with this said, I would like to thank you for your attention, and I look forward to any questions and feedbacks you might have at the end of the session. Yeah, thank you.
Great stuff. Thank you, Dr. Joyce. Really appreciate that. So let me introduce our next speaker, Mark Andrew Hernandez from Amsterdam, Netherlands, to present on private 5G over satellite, enabling private 5G networks via satellite connectivity, bridging remote and critical communications.
Okay, good morning, good afternoon, everyone. So let me just share my screen. Let me know if you can see my screen.
Yes, sir.
Okay. So let me just introduce myself. This is Mark Andrew Hernandez. So I'm head of the solutions engineering here in Europe, based in the Netherlands. So what I'm going to discuss today is about the private 5G over satellite. So how we are able to provide or support our end customers or even users to bridge the gap in between the services that they would try to offer in specific applications. So this is my favorite first, of course, to understand how the satellite works.
6, 5, 4, 3, 2, 1. Engines full power and liftoff of FBS Power. Go Falcon 9, go FBS. Vehicle switching downrange.
So what you're seeing here is about launching a satellite through space and what will be the service across, right? So SES is basically a multi-orbit satellite operator. We have 43 wide beams, or what we call a geo satellite. Out of these 43 geo satellites, we have 4 high throughput satellites. So meaning from a typical satellite bandwidth of say for example 500 meg, we can have it more higher throughput than we can have on the classical satellites. And then out of this one, we have what we call a MEO orbit satellite. And these are, again, I will explain in the next slides how this is basically how you can classify multi-orbits and how can it apply to private 5G. Now, dwelling on this private 5G, I would like to introduce how it's beneficial private 5G to not only for a corporation, but also for a multi-user. So private 5G offers a high-speed connectivity, as we know. It has a lower latency, and it increases security over a public network. We already have like MNOs already have providing the public 5G, but the private 5G also have like an owner or a corporation can allow a customized network settings and control, making it ideal for critical communications. I will present a user cases or user application how we can provide a private 5G to a corporation. So enabling private 5G over satellite network, it can provide a private solutions not only to extending to a remote, but it's also create a stable communication between a critical places. Enabling a private 5G over satellite, you can extend, the area without the traditional fiber or microwave link. So this is basically the advantage of a satellite over a private 5G networks. So the benefits and the challenges of a private 5G networks, it can improve your security, right? And it's of course, it's reliable compared to a public networks. When you having a coverage, you can customize a specific requirement to have a better network, right? The only challenges in a private 5G network, because these are like a specialized equipment, and somehow you need some kind of an expertise. So you need to hire a person or a group of person or a partner that may require some kind of that kind of skills to deploy a private 5G network. And again, this is a one-time infrastructure, and it is costly, and of course it's a bit of a time consuming, right? So these are the typical challenges of building a private 5G network. So building a satellite or the private 5G over a satellite is the advantage really is your global coverage. So from just being in a rural area, you can even provide this service in a mining sites or in an oil rig. So these are the typical areas that we can support private 5G, So aside from this one, the global connectivity providing private 5G, we can already provide some kind of application, not only to a typical architectures. So we have a project in French or French Alps where we have it's not only for the tourists, the skiing, but also for the agriculture. These are now being applied, like for example, providing IoT service or edge compute on the remote areas where it's really critical to provide a communications within an applied service that we can accommodate to provide the private 5G networks. So to give you some idea, what are the typical orbits in a satellite world? So I don't know if you already heard about the GEO, MEO, LEO. So the GEO is basically 36,000 kilometers satellite, which you only need 3 satellites to cover the full global coverage. And then we have the MEO. MEO is a medium Earth orbit satellite, which is around 8,000 kilometers above Earth. And you require at least 6 satellites to make it global. And it has a low latency. It's 150 milliseconds of latency. Of course, this latency requirements is vital to what applications you're going to provide. And for a private 5G, there are applications that you will require latency sensitive services. Say, for example, for the Teams call or for the cloud services or edge compute, somehow latency are vital to provide the service. And then LEO service. So LEO is like low Earth orbit. Typically, these satellites are within 500 to 1,000 kilometers above Earth. You already know or you already heard about Starlink and OneWeb. There are thousands of satellites just to cover the global coverage. And of course, having a satellite that is near to Earth, meaning that is basically a almost 10 to 50 milliseconds of latency, right? So enabling a private 5G network over satellites, it's really provides you a vital infrastructure that you provide connectivity solution to a remote and not only for a critical communications, as I said, through mining, through oil rigs, or even to a disaster recovery situation. Also, satellite can do backhaul solution. So what is backhaul? So basically, if you are providing a network or a pool of bandwidth to a specific location, backhaul means you have applying a bit of capacity, a huge capacity that you can you can shoot it to the specific location, higher location. So somehow, sometimes microwave fiber may have some kind of limitations. That's why you have to use the satellite connectivity or satellite network. Terminal solutions for private 5G network is also required because some of the infrastructure may require a small terminal or less space consumable terminal. So like for example, the flat panels. So these are vital when you are applying or designing a network over satellite using a private 5G network. Okay, so these are the typical setup. You have your satellite, and then you have a terminal. Terminal can be a flat panel, or it can be a dish, and then it's connected to a private 5G. So private 5G can be Nokia, Ericsson. There's a lot of players or suppliers that provides a private 5G backbone. And the applications that you can provide after the private 5G is you can have your IoT sensors, edge compute, machine vision. So these are the typical critical applications that you can offer or we offer to our customer to make sure that they can have a service, vital service, secure service, private service that they can apply across their locations. Okay. So these are the typical segments that use private 5G: mining, the public safety and the government, the energy and oil gas, and the maritime, military applications, and disaster response. So when you're applying private 5G, these are really a dedicated network that you support to a specific applications. So again, there's a public 5G that provide supports or provide service through a rural or urban areas, but private 5G really, for example, in Africa, where mining and energy are being applied to a specific locations, where rural 5G or public 5G cannot support, or even the submarine cables or even the microwave cables. So they really require a satellite connectivity to provide these private 5G applications.
Hi, Mark. The
yeah.
time is over. The
Yeah,
time is over.
okay, so like I just want to have some kind of conclusions why the private 5G over satellite is important. Of course, one of the reason is basically you can extend the coverage to the remote locations. You can improve your security, and it's a reliable networks. That's all. Thank you very much.
Fantastic. Thank you, Mark. Really appreciate that. Let me introduce our next speaker, Eren Sekli from Istanbul, Turkey, to present on trend and developments in Open RAN.
Hello, good morning, everyone. Can you all hear me?
Yes, sir.
So let me pull my presentation up the screen. Just wait a second. Can you all see that?
Yes.
Fantastic. So welcome again. My name is Eren Sakli, and I'm working as Open RAN product integration and performance engineer at Vodafone Group, and I'm based in Istanbul, Turkey. And today, I would like to talk about the latest trends and recent developments about open radio access networks. Let me walk you through my agenda first. So I'll start with the definition of Open RAN for the newbies, and then I will address the need for Open RAN. Why do we need? Following that, I will be covering the latest trends and recent developments in the domain. And like every advancement in the technology, there are some challenges to address. So we will talk about those challenges. And finally, I'll talk about the future outlook of Open RAN and address what to expect from the next generation networks. So we all hear that the future of telco networks is evolving through the openness, collaboration, and interoperability. And Open RAN, or ORAN, stands for the Open Radio Access Networks. And in its core, it is standardized and open interfaces between the network elements defined by an organization called ORAN Alliance. And this alliance was established in 2018. So basically, it is splitting the proprietary monolithic hardware into 3 functional units and unlocking the interfaces between them. So if you look at the key components, we have centralized unit, where non-real-time processing like management functions and higher layer protocols are managed, connected to the distributed unit, where the real-time processing and high portion of the physical layers are taken in place. And finally, we have the radio unit, where the radio frequency functions and the low portion of the physical layer are handled. So if we compare this with the legacy systems, where all components and systems are closed, Open RAN modular approach, enabling mix and match components from different vendors, that promotes competition and drives down the cost. And the key concepts are interoperability, scalability, and innovation. The openness nature of the network enables fast integration of new technologies, facilitating innovation and enhancing the network performance. And finally, it's a huge ecosystem. The ORAN Alliance has more than 330 members, including the element-specific stakeholders, industry alliances, along with the government bodies. So it's a harmonized collaboration. But why do we need this? Because we know that the legacy approach can't meet with the evolving network demands, and we need something new, something disruptive. The networks used to be metric driven, and it was sufficient to have higher throughput while consuming less power in a cheaper way. But now the networks are use case driven, and they're purposeful in different verticals like healthcare, industrial, media and entertainment, and so on. So we have evolving network demands, and with its focus on both horizontal and vertical disaggregation, Open RAN is allowing virtualized functions to be deployed on cloud servers and make it possible to meet requirements of next generation networks. And we used to have challenges with the traditional RAN. It was highly vendor dependent, resulting in high costs and lack of agility and innovation. But conversely, Open RAN fosters innovation, allows adaptation of new technologies such as artificial intelligence and machine learning or cloud-native deployments. Finally, it also has some economic benefits such as cost reduction by competition or addressing the geopolitical concerns, and it also creates new jobs in the market. The trends. So we know that it is not just a fleeting trend, but a substantial shift towards efficient, cost-effective, and flexible networks. By 2024, more than 100 unique operators commercially launched or actively testing O-RAN globally, as you can see on the right-hand side on the map. Asia is leading the rollouts by having 30% of it, while Europe is following it by 20%. And greenfield deployments where the new networks are built from scratch, having the initial attention. But looking ahead now, the focus shifts to brownfield deployments. And the notable trend in the brownfield deployments is the adaptation of hybrid architectures, which operators combine legacy systems with the new Open RAN components. And it has highly cost advantages and also allowing operators to leverage their existing infrastructure. Cloudification, and operators now leveraging the best IT principles of cloud infrastructure in the telecom domain. And by transitioning from traditional bare metal infrastructures to cloud-based environments, Open RAN has enabled operators to become more agile and responsive to the market trends. Millimeter wave. So it is best suited for densely populated areas in the city to ensure 5G services, and it can provide 5G coverage and capacity in certain venues. The disaggregated Open RAN architecture allows deployments of various types of equipment, having interfaces defined by 3GPP or O-RAN Alliance. And last but not least, non-terrestrial networks. The integration of NTN with terrestrial networks offers seamless connectivity across remote and underserved areas. And the key innovation is the implementation of digital interfaces between the virtualized RAN and the satellite beamformers. And what are the recent developments? So working groups, or WGs, as you wish to call, are continuously updating the specifications and introducing new developments. These are network energy saving capabilities, such as cell carrier switch on-off or sleeping mode of the radio units. Another thing is the demodulation reference-based beamforming. So uplink performance and front-haul bandwidth savings can be improved using demodulation reference signal beamforming. And it is essentially moving some functions from the DU to RU. And this is named as uplink performance improvement. Security solutions. O-RAN continues to pursue zero trust architecture, and WG4 adopted a new ability to protect the front hall's control and user plane protocols with IEEE 802.1 AA MACsec. And CBRS support. As you know, CBRS is a shared spectrum operated in the US within band N78. And recent enhancements to the O-RAN Alliance fronthaul specifications enables a radio unit to measure received power and report those measurements to the SAS. And finally, NB-IoT, narrowband IoT. It's a 3GPP-defined low-power wide area network technology, And with the recent developments, ORAN WG4 introduced the support of NB-IoT in the front-haul specification. What are the challenges? Of course, there are some challenges to overcome with. And these are interoperability issues, because introducing elements from different vendors may result in interoperability difficulties. And there needs to be a set of open standards. However, like it is in progress and being made by ORAN Alliance, there are still some interfaces and protocols still lack maturity. Integration complexity and multi-vendor model. The new systems are more complex and we have some skill gaps. Operators and engineers require training to manage disaggregated systems. And when an issue arises in the network, identifying and isolating the issue become more difficult because the environment is more complex. And even once the issue is found, a vendor can pass the blame to another vendor because of the complexity. Performance limitations. Open RAN systems sometimes struggle to match the low latency performance of traditional tightly integrated models. And finally, security risks. Security is an essential aspect of any technology, and the threat surface area increases as more vendors are onboarded, especially through their interfaces. And open interfaces increases the risk of cyber attacks due to the open nature of interfaces. And my final slide, the future of ORAN. We know that Open RAN is a catalyst for 6G, facilitating open and intelligent networks and reshaping the future of telco. There is a task force called the Next Generation Research Group, and they are actively conducting research streams, areas focusing on AI, ML, because we know 6G is envisioned to be AI native, and the AI ML applications in 6G will be comprehensive and expected to operate in real-time manner. Security, real-time analytics, softwareization and disaggregation are the topics that we are going to see and hear more often. And finally, I can talk about sustainability. Sustainability and energy efficiency should be the basic design criteria for the future systems in order to fulfill the United Nations Sustainable Development Goals. The energy bit consumption must be drastically decreased or stay at least on par with the current power consumption. So my final slide, call to action. For further information, discussions, or to connect, you can add me on LinkedIn or send me an email through my personal email. You can see on the screen. And I would like to thank again for this great opportunity to Kanish. And I'm stopping here.
This is fabulous. Thank you so much, Aaron. I appreciate that.
You're welcome.
I would like to introduce our next speaker, Adela Mehik-Zanik from Vienna, Austria, to present on what is hot in IoT.
Thanks, Ganesh. Thank you so much. Let me start, like as everyone else, by sharing my screen. Well, good morning, everyone from Vienna. Pleasure to be here with you all. It was very insightful morning with a couple of great talks, and I thank you, Ganesh, for putting it a nice agenda together. I think it comes very nicely. The one that I have to present now, next to Aaron, was talking from the Vodafone Group on the future trends and opportunities. So what's hot in IoT? It's a nice topic, and there's a short and long answer to it. Well, you heard a couple of presentations. I think Giorgio started the first one with saying that everything goes around the AI. So if you just Google it for the sake of it, what's hot in IoT. So there's a bunch of, on the first Google page, there's a bunch of information and, flyers and so on, all related to, incorporating the AI capabilities, AI ML into the existing stack. I myself have been in the IoT industry since it's been called machine to machine and big data. That's pretty long. It's about almost soon 10 years now. And it's, for me, sort of reassuring knowing that the fact is that, there's a lot of trends, and it's good to have trends. It's good to follow them. There are some great analysts in the IoT industry that can, that publish very qualitative research, such as the Berg Insight or Transform Insight, and others that you can, look and follow specifically on LinkedIn, for instance, that give such a good overview and put a lot of trends. The reality of the work that we do, most of us here, is that we tackle the telco industry. So like we are working in the telecom sector. I myself have been responsible, or I'm responsible for the business development in the Western Europe before coming to Mavoko and being on the software side of the business, building up one of the best in class IoT connectivity management platforms. I myself was in the telco industry. I was working for the Tele2 IoT Swedish telecom operator globally that was launching various applications in the IoT through various partnerships, very horizontal approach, very innovative approach. And what I have learned over the last years is that, since I've been on the telco side, is the fact that, these trends are important to, look at them, but they are also with the caution, making sure that, that the telco industry is, with all due respect, and not the fastest moving industry. It's the one that requires, analysis, deep analysis. It requires consultative approach. It requires strategy. It requires putting into place proof of concepts and so on and so forth before, land on the, clear, let's say, clear and thoughtful approach and decision that this is the way going forward, specifically when we are the ones who have to, engage in the trends that's coming up, like the AI. So you have to act very fast, but you have to make sure that you have such a long tail of, partners, customers, applications, and so on and so forth, that you need to engage in such a way that it makes, everyone moves in the right direction, which is often not the case, which is often not always possible, and it's very challenging considering that the this end-to-end ecosystem is quite a long one. So here are my contacts. So anyone that wants to get in touch and has further questions around, that's my email address from Mavoko, and this is also my LinkedIn profile. So please do get in touch if we don't get the chance to answer some of your questions during the session today. So being in the industry for that long time, and if some of you remember the fact that in 2015 or 2016 there were big reports from Gartner saying that there will be billions and billions of 50 billions of devices connected by 2020, 2025. There was like big years in the IoT industry, and everybody was looking forward to that. And there was like a lot of attention to it. Everybody was, all the companies, partners that we were working on, they were like looking into ways how to engage as soon as possible, to be the first on the market, to beat the competition, to launch the innovative devices. And the notion back then, everything needs to be connected. So in a way, we were saying that everything that moves should be connected, or like we connect everything from a building to giraffes in Africa when they were moving from one park to the other, making sure that they have the right conditions. So the same motion in IoT stays as of today. So 5, 6, 7 years later, it's the same motion saying that we want to keep connecting devices. There were a couple of things that were mentioned here, like the 5G. There were things that were mentioning like sustainability. So all these important issues from the technology and as well environmental point of view. So it's the way at Mavoko that we are looking forward at the ways how we can help our customers and partners to do that. So to grow because we want to, telcos want to grow. So there's still some skepsis about the opportunities to connect, hundreds of billions of devices over cellular. It can be also not just cellular, it can be satellite, where like one of my colleagues was presenting before. So there are different ways how you connect the devices. And the idea back then in 2016 and 2017, if you read the reports, and now today with the possibilities that we have with the AI, is that we can capitalize on those on that data. So basically the idea is back then that we have started in 2016, 2017 was the fact that we connect everything. So there were simple ways, and it was all about predictive maintenance. If you think about a simple coffee machine, we wanted like that you have at your office or that you have at the airport. So the companies that were launching those connected applications, they wanted to know how this machine is working. And they wanted to make sure that they know when they need to send their people to that spot, making sure that they don't send someone just for the sake of it, but they have known this information upfront and they can handle it, and they can ensure the whole ecosystem around it, who needs to be where, when, and how. So that idea is still there. So that's the starting point of it. Now with the new tools coming along, it's the motion. So how to make it even smarter and more automated and more intelligent, so that there's less and less interaction from the human point, right? So our customers are telco operators globally. So also telco groups that are capitalizing on the IoT, and they're making sure, so they're coming to us with the question, so how basically they could make sure that their service, for instance, is so intelligent that they can optimize the ways how their devices, how much data they use, so that they can optimize the ways and automatize the ways how they diagnose and make sure of those devices, and how do they know which devices might be crooked devices or which devices are the ones that should be looked into it, because they are creating so much unnecessary traffic in the network, so that they know already upfront, and that they don't have to go into the millions and millions of records of the data to make sure that they know which device needs special attention and care. So this is the ways that the telco, and I've been talking today specifically about the telco because that's the motion and the major customer base of the company that I work, and IoT is very much in looking forward toward the telco operators and trends that they follow. So that's the ways how the telco operators are looking into to make sure that they use the best of the best platforms, initiatives, technologies nowadays to ensure that they offer a great service, that they grow, and of course that they that they grow their customer base, and that they offer innovative solutions to the market that have not been seen before. So just give you a simple example. So if you have been last year at the Mobile World Congress in Barcelona, there was an interesting motion, and that was, if you have come there without knowing that it's about telco operators, connectivities, all these nice things, and you would think that you came to the AI show, and that's the true fact. So I'm looking forward to these years, but the last years was all around different use cases, various use cases. Telco operators and groups around the world were showing how they are using the AI at the moment, or variants of it, so that they can offer better and better solutions in different verticals, be it a smart meter, be it a smart lighting, be it everything around smart agriculture, everything around intelligent, automated, and optimized ways of using it. I believe that's my time for today. So I will leave it here. You all have it, my contacts in the presentation. So please do reach out, and let's continue this conversation. There's a couple of trends that I'm really excited to share with you. This was just a tip of an iceberg. Thank you.
Fantastic. Thank you so much, Adla. I really appreciate that. Let me introduce our next speaker, Dr. Mai Elisa from Erlangen, Germany, to present on 3GPP Release 19.
Hello, good morning, good afternoon, and good evening. My name is May. I'm a postdoc from University of FAU, Erlangen, and I am a 3GPP delegate. So unlike the common knowledge about 3GPP, we don't do standardization, but we do lots of specification, which goes to our standardization bodies. So in today's talk, I will try to start with the relation between 3GPP and the different generations of telecom. And then I will talk in specific about the 5G advanced in release 19, the current one, and the road to 6G. And then how to connect this with the working groups from the 3GPP, and especially in the RAN case due to the time limits. Then a timeline where we are and what's coming next. So let me start with first release 19 is the second release talking about 5G advanced. So with the 5G, we had three releases, where in release 15, we had a focus on the EMPP, and then there was the expansion to industry. And in release 17, we see the lower complexity, the NTN was introduced, and now we are in a place where release 18 is already freezed. And we talk about what we do in the release 19. We go to 6G and what 5G advanced is offering us before we start moving to the release 20 and 6G. So when we talk about 5G advanced, what was required and what was not yet there in the 5G, we talk about experience. So we move from just defining requirements to enriching the experience which we had in the previous releases. We want to extend our targets and to go to more cases where we have NTNs and IoT. Optimizing our operations from the experience which we get and moving to a higher level of lower power and more efficiency, especially in the energy. And also, after we enrich our experience with the 5G advanced, we want a bridge. So we want to extend and to move further to the 6G and beyond. So from these requirements, let's see how release 19 was structured. So we have different area of focus, and I would like to talk a bit about these areas here today. So what's in release 19? Basically, there was AI ML, so artificial intelligence was a huge topic. Of course, the beginnings were already in the release 18, and we extend lots of studies coming to the interface and also to efficient energy and trustworthiness, AI ML. The other big topic was MIMO. MIMO was a big part of the release 18, but the MIMO, which was introduced, the study cases in the release 19 was more about reducing latency and moving from the 32 case to 128 for a better support and to coherent joint transmission, so optimizing multi-site performance. We talk also about mobility, so LTM enters U handover, enabling also low latency, and we talk about a higher reliability using a conditional LTM, which ensures handover not only when it's needed, so increasing our reliability. There is some cases studying the full duplex, so subband in the full duplex, which means mixing the TDD FTD for stimulus uplink downlink with the same carriers, which is boosting capacity and lowering latency. Other highlights in the work of release 19 was the extended reality support, so improved scheduling and link control for a better XR experience. multi-hub side link relay, which extend coverage for public safety, NTN enabling 5G via satellites. My colleague was talking about this topic for a broader IoT, and support battery-free devices using ambient IoT. AI was a big topic, and also one big thing was the introducing of a new channel modeling for Isaac cases, so integrated sensing and communication, and especially in the band between 7 and 200 gigahertz, so preparing for the 6G studies. As we said, the main concepts and the main goals of the release 19 was in the 5G advanced and maturing it, but we also have some studies showing cases about the Isaac and the channel modeling, which goes directly moving from a study case to a work item for the release 20 and beyond to bridge to the 6G case. So due to limit of time, I will talk only about the RAN, so radio applications. And if you take a look in the RAN 1, this is the cases which was been studied. So if you are curious and don't want to wait for the release of the study, you can read the reports. So RAN 1 worked with a channel model, the channel modeling and the ambient IoT. We have also some cases of the MIMO development, the duplex case, and also the air interface AI. RAN 2 talked about the mobility cases and special cases for the extended reality and NTN. Then we have the case of the RAN 3, where also cases of AI is explained, and also the topological advancements and the SON cases. And then the RAN 4 had all the enhancement parts of the radio. So lots of enhancement and developing. And you can see the study cases. And this is just a reference. If you have more, if you'd like to have more info, please go back to the report. It's all available in the 3GPP website. So now we are to 2025. So the release 18 is freezed, and now we are beginning of this year. So we expect by the middle of this year to have the first freeze, and then end of this year we'll have the version of release 19 ready. So 1 year after, we go to the study cases for industrial applications. So the completion of this release will be end of this year. And in summary, yes, release 18 was about 5G advanced. Release 19 is realizing the full potential of 5G, and then bridging to 6G with a new spectrum and with a new system and applying AI technologies. So this is my references for today. So basically 3GPP, and thanks for the Nokia white papers. And thank you for your attention.
Fantastic. Thank you, Dr. Mai. Really appreciate that. Let me introduce our next speaker, Abdelhak Fodil Paris, France, to present on 5G monetization, challenges, strategic recommendation, and opportunities. Over to you.
Perfect. Do you see my screen?
Yes, sir.
Yes, perfect. I will also try to put my camera. Perfect. Thank you very much for this invitation, and thank you, colleagues, for your presentation. My name is Abdelhak Fodil. I'm based in Paris, France, and I have almost 20 years experience in telecommunication sector, especially in mobile network from 2G to 5G now, and in some years 6G. From my side today, I'll be speaking about how to maximize the 5G economic value. As you know, the first commercial launch of the 5G took place nearly a half decade ago. By now, we are all familiar with the potential of the 5G, especially for the industry. And just before Mia present very well the release, the 3GPP release of the 5G. However, what we have observed in the market is that the 5G still lacks strong penetration, particularly in vertical industry. So today I will not speak and I will not focus about 5G speed, latency, and technical features. It's important also, but instead I will try to present and provide you an overview of the key challenges that the industry face in adopting 5G, explore effective strategy for its implementation, and highlight a real-world success story from France. By the end, I hope by the end of this presentation, I can inspire some ideas to unlock the full economy potential of the 5G. Let's dive in. The insights presented here are based on my research to have the MBA thesis at Sorbonne Business School. The study focuses on a key question: how can we economically leverage the power of 5G for the verticals, particularly the industrial sector? To address this, my approach included concluding a qualitative study of the 5G ecosystem in France, interviewing over 15 key stakeholders, including operators, vendors like you see Ericsson, Nokia, presented in France, the manufacturers, and also industry leaders. I take all this information and I have used some strategic tools to understand the barriers and to enable the 5G adoption. So let's explore the finding together. The major, as I told you, we still have challenges to adopt 5G. First, I have noticed in the field that the traditional business model, where the company wait the vendors, the operators to provide a solution without actively engage in the ecosystem, can present an important challenge. It is preferable for the company to be in the center of the ecosystem for the 5G implementation project. However, not all the companies have the capacity to achieve this this one by their own. This is why the role of the regulator, each country regulator, becomes crucial in establishing and facilitating a supportive economy. We have seen in United States and also in Asia, in some countries, the government are really present to accelerate the 5G. We in France we are taking this these possibilities to encourage the industrials. Another challenge that I have noticed in the field, there are all times the problem of the how we can say the convergence between IoT and OT. So sorry, the operational IT, the operational technology, the tool of the industrial, the IT, and the telco. While the integration of the OT and the IT is already in progress to adapt the principle of Industry 4.0, adding telecommunication layer, additional layer in this mix may complicate further the process of the convergence. So the teleco is a relatively new domain for many industrial sectors. Last but not least, as you know, the primary goal of the major industry is to achieve a strong ROI. When there is significant investment, especially in the earlier stage where the use case are not be clear and visible, the industrial hesitate to take the risk in adopting new technology. This is particularly true when they have already made long-term investment in tools, and this take typically the life span take 10 to 15 years. This is why the industrial who is trying to adopt the 5G, he need well-defining a strategy and effective one. First stage is it is essential to define why the 5G could be a game changer for the industry. Of course, calculating ROI is crucial, but it should include both the initial use cases and the potential future application. One key factor also it is important in this stage is ensuring that the stakeholders from the board are involved in the involved understand the importance of the 5G for their company growth. The second phase is selecting the right partners, the vendors, integrators, and the operators. It is important also to ensure that this process include change management within the organization, as it is significantly important for the structure and the operational part. The third phase is concluding POC, which is highly recommended. This allows validating the initial use cases and ensuring that 5G is effectively integrated into the operational process. After this phase, the industrial can launch its project to expand 5G across all the sites. It is crucial to keep the old technology in service as a backup during the initial months or even years to ensure smooth transition. Once the 5G network is operational, it must be monitored. For this, there are 2 or 3 options. So the company can choose to maintain it by internally by an IT or training an IT team or creating a new telecom team, or maybe outsource with an operator. We have also a third option: keep level 1, level 2 internally, and outsourcing the complex task. The final step focus on the technology evolution. The 5G, as Mia before me explained, we are now in release 19, so we have new innovation, so we can introduce this also in the company which adopt the 5G. I will present you now. In France, we have several companies that have successfully adopted 5G by using a clear strategy. So today, I will share you an example of ArcelorMittal based on my interview with their digital chief. He told me before 5G, the company used Wi-Fi, Tetra, and other standard, but faced significant coverage issues due to the metallic environment. ArcelorMittal is specialist in with metal construction. So he chose to move in a 5G network. So as we see here, ArcelorMittal conduct a project by a partner as Ericsson and Orange Business, and also with the government as which help them with some financial part, and ARCEP also the regulator for the frequency and some other issues. David Grigi, the digital chief, told me that the coverage, if really they use the Wi-Fi instead the 5G, he could invest 7 times more than which it is invested with 5G. He told me also with 5G, the company gained 15% in maintenance efficiency and no longer need to multiple devices. And also thanks to the 5G and the low latency, he could introduce autonomous train. They improve also the indoor coverage, and they leverage with the 5G to achieve significant progress in their decarbonization effort. Yes, to conclude, we have seen that the first thing which is important is to align the company strategy with the 5G transformation project and engage all the stakeholders from the beginning, make a POC first, launch a project, and adopt monitoring strategy internally or outsourcing. It depends in the company strategy. It is if all this it's well done, for sure the company can have benefits and growth, and of course the ROI will be maximized. So this is all from me. So this is my LinkedIn if you want to connect, and I hope we can participate in another also global 5G evolution. Thank you very much.
Fantastic. Thank you so much, Abdelhak.
Okay.
I would like to introduce our last speaker, Ayat Zaki Hindi from Luxembourg, to present on integrating network digital twinning into future AI-based 6G systems. Over to you.
Thank you. Hello, everyone. Thank you for giving me the opportunity to discuss our work through this platform. So my name is Ayat Zaki Hindi, and I'm a researcher at Luxembourg Institute for Science and Technology. In the next few minutes, I will present our ongoing work in the 6G Twin project, which is a European Union-funded project by the 6G SNS, and it's focusing on integrating network digital twinning in future AI-based 6G systems. So just a brief introduction of SNSGU. It's an entity that aims to advance 6G research in Europe. It enables pooling the EU industry resources into smart networks and services. The 6G Twin project is part of the portfolio for the Stream B system architecture, as you can see from the timeline here, that this project started in January 2024, and it's of a duration of 3 years, which is aligned with the 6G standardization kickoff, which enables our results to be disseminated into standardization efforts for 6G. It's a collaborative project which involves 11 partners from 8 member states, 2 leading research organizations, 3 universities, 3 SMEs, and 3 LEs. So now I'm going to move to the motivation behind this project and talking about beyond 5G. As we can see from previous talks, that we are facing the rapid integration of digital technology across industries like transportation and manufacturing, which needs more and more efficient communication and computing services. And the networks themselves are becoming increasingly complex because of the large variety of technologies that operate the 6G system. So with the 6G effort is planned to be deployed by 2030, it's essential to start the design and experimentation work of new architectures, which includes intelligence and automation. And since the European 6G roadmap prioritizes AI native management, we will need to create a unified communication and computing architectures, which is a result from collaboration among standardization, academic entities and industry leaders. So the overreaching objective of the project is to provide the foundation for this design of AI native reference architecture, and to do so we incorporate the concept of network digital twinning. So the network digital twin means creating a real-time digital replica of the physical network and creating a sandbox where we can try a new scenarios and train models before deploying them on the physical network controllers. So I'll present here the concept of this architecture that we are proposing. We are proposing an architecture of 3 layers where we have the bottom layer physical network, the second one is the digital network, and human world, the third one. So the physical network it includes the network infrastructure like the radio access network, the core network, but also includes the environment and the user equipment and all the factors that affect the performance of the communication. And on the other side, we have the human world where we have the network applications where we provide the KPIs needed for use cases like teleoperated driving, energy saving, and so on. The most important part is this digital network layer, which includes this twinning capability. As we can see on the left-hand side, we collect data from the physical network. We harmonize this data in order to create basic models. Here, what we mean by basic models is the representation of network components, and they are based on real-time data feed to this digital twin. Basic models also interact with functional models. Functional models are objective specific, like network planning, network management, or traffic analysis. Functional models are related to the network application that we are considering and the KPIs that we have. And from this interaction and orchestrating these models and data, we create an open and secured NDT modeling, simulation, and management framework. So what are the specific objectives now? So from one area is to advance the state of the art. First of all, we are aiming to develop an open and federated AI native network architecture for future 6G systems that enables intelligent data analytics and decision-making in real time. Another specific objective is to design this middle layer that I just presented, which is presenting the network infrastructure with a graph-based NDT that accurately reflects the dynamic and the complexity of the network scenario that we have, and creates the sandbox for optimizing and testing new scenarios. And the specific objective 3 is to implement the accurate, reliable, open, and secured modeling and simulation framework, which represents the network environment and tests the functionalities of this architecture. We are not going to stop at theoretical level. We are aiming to demonstrate our results and validate them through 2 demonstrators that focuses on 2 key areas like teleoperated driving and energy efficiency for networks. And the third area is the adoption. It's very important that the results proposed by this project are to be standardized for a future interoperability among platforms, and to ensure harmonization between future solutions. We are also going to provide insights for businesses based on the vision of 6G Twin. So here I will just provide a brief overview of the timeline and the core activities that we are having. As I mentioned earlier, that we started in January 2024, and we started the work on 6G architecture design and the network digital twin modeling. We also started implementing this simulation framework that incorporates multiple simulators that represent the real network for the two demonstrators that I've just described. And by the end of this year, we will start implementing this proof of concept on real testbeds. We also aim to evaluate our results and disseminate them into standardization entities. So that's all from my side. Thank you.
Fantastic, Hayat, Zaki. Thank you so much. Really appreciate for your contribution. I would like to request all the speakers to switch on your cameras. We have like about 10 minutes or more to have a Q&A session, and I really appreciate that we'll have a very lively discussion. The first proposed question is, what are the top trends in the telecom sector for 2025? Anyone wants to take it up? Maybe I will kickstart to warm up first. Based on my knowledge, I think there's few areas that we should look into is the beyond connectivity, like a value-added services. I think security is one of the areas, managed services, application enablement. GPU as a service also is quite important, where NVIDIA is partnering with all the telcos, and this is something I think really most of them are trying to offer such kind of services. Network slicing is quite complex because it takes about end-to-end connectivity, so on and so forth. There's fabulous trials that are going on, charge premiums for those tailored services kind of thing. Network as a service or infrastructure as a service is another key area. A lot of discussion we heard here today, private 5G networks. There's also a lot of discussions going on in terms of the convergence of the LEO or satellite services together with the mobile network cellular. Those convergence are taking in place. I think the more discussions is coming into place in the main forums in ITU discussions as well in the next 3 years. Industry-specific solutions, it can be a tailored manufacturing or healthcare or smart cities, independent kind of solutions can take off as well. Platform and ecosystem monetizations like what they call the partnerships with the developers. The API is another area that can take off together with the developers to generate those kind of revenues. Data monetizations like through analytics, insights, data-driven services, edge computing as well, enabling the low latencies. And the EMBB is another area, URLLC another area. I think manufacturing is one of the other areas as well. Not forgetting like robotics discussions, a lot of those discussions is taking place. Artificial intelligence, there's a lot of discussions or has already been implemented. I think there's quite a number of big giants, like for example, NVIDIA, Tesla, the Optimus Robotics, and also quite a number of prominent Chinese companies in China also have came out with innovative drone solutions as well. So this can be also another way of offering services or drone as a service by the telcos towards to the end market. As you see, those were the days the 3G, 4G was very much of a consumer centric, but today we can see there's a lot of driven towards to the industrial specific. or business-driven specific as well. Not forgetting metaverse, AR, VR. I think that is also is favorite as well. Maybe I should stop from my side. Anyone wants to take it up on your side, please feel free.
I mean, you summarized it mostly, Ganesh. So there's quite a lot of trends from any angle that you look at it. So I tried also to mention in my presentation that on the side you have the trends, and the other side you have the adaptation of it and adaptation of pieces and parts of it. What I would also agree with you, what I have seen, because we work with large telco groups and operators worldwide, and I specifically look after the Western European market, is one of the points that you picked up was the security. And that's definitely getting up on the priorities, and they are handling it in different ways. So I have not seen I would say unified approach. I see a very group-wise ways and approaches. In Europe, you have to also be aware. For instance, if you look at the Nordics, you have to be aware of the geopolitical situation as well. So there are telco operators that 2 years ago have come up with national strategies, putting the IoT under the critical infrastructure. So if you classified because they are, so imagine if you have a connected emergency device, if that cannot get through, or some power plants and everything is getting connected. So basically, I, for once, have been very happy, to see it, because as I mentioned, I've been in telco for a very long time, and back then security was put aside, honestly. So it was something that you have to deal, not just telco, yes, but if you work with the customers, because they are at the end of the day bringing up the devices up to the telco network, telco is providing a connectivity and managed services and but on the customer side, it was dealt a little bit. Something comes later when we have a large scale, large base and now I see it's getting, from the telco operators, it's being really pushed, streamed down. And so it's being taken very, very seriously, which should be. And there are different ways and approaches. And, I'm learning actually every day, because there's so much to be learned in that area. So that's definitely one. AI, of course, as well, as you said, but it's really so different from one to the other operator, one from the other region. So I know that they are looking into different applications, because at the end of the day, you can write the most beautiful strategies, but you need the partner ecosystem. So that's what I was mentioning back then, is that you cannot do it by own. The telco that realize that they can do it as an ecosystem, that every partner does their piece of it, they can benefit and roll out something very quickly out, so to test the market and see, how does that perform and how the market goes. And to be honest, if we say 2025, the 1 year in telco world is nothing. Really, it can be that there's a lot of trends, but I work mainly with RFPs and RFX, and it takes years, to get things rolling. So that's also something to be really aware of it. One thing is like you have the slides and road shows and strategic partnerships. On the other hand, we have to be aware of the fact that to get it down rolling, even to connect one street lamp so that you can showcase it at the let's say Mobile World Congress, it's a lot of effort to put in place, and that's just as it is today. I hope it's changed as in the future.
Thank you, Adela.
Yeah. Just like to add to that security point, I think what we're really seeing is the democratization of security.
Georgia, I can't hear you well.
Just tune up.
Sorry, is that better?
Yes.
Yes, okay. I would just add that I think what we're seeing is the democratization of security, particularly because of that move, as you mentioned, Ganesh, towards those as a service models. Because of that increased flexibility, really strong, robust, up-to-date security is no longer the exclusive domain of tier one operators. Now it's accessible to anyone. So I think that accessibility and that flexibility that we're seeing is really driving evolution. and of course, securing the whole ecosystem as the sort of holistic level is raised.
Right.
Yeah. In my opinion, I think also I see many mentioned also in the presentation. Like I also mentioned, I think that's the core of like industrial metaverse or metaverse. This concept is also the interoperability of the system, like this platform approach, and how do we build this ecosystem where can have the open data sharing, but of course with security and the access control, but also this collaborative approach. I think that's what I'm looking forward to.
So that means we can see a lots of partnerships, collaborations in 2025. I think that was, I mean, we can notice there's a lot of technology vendors and also the mobile network operators, marketing research companies are collaborating each other to see how they can able to come out with innovations. So yeah, you're perfectly right.
Absolutely.
Anyone else? Oh yeah, Aaron, please.
Maybe I can echo what my colleagues and fellows said here. It is like in the essence, network operators or other service providers would like to monetize their services. In order to invest the new technologies, they need to make money on that. So this is the long story short. And for this one, they need to disaggregate and liberate the hardware and also avoid the vendor dependency to add more features to the hardware and the software capabilities. So technologies like Open RAN, as I mentioned, liberating the hardware, and you just put servers on the edge, and you have spare compute, cores, general purpose cores to inject or embed functions, services that operators or providers can monetize, like artificial intelligence type of services or platform services or cloud services, whatever you call it. So we will see more liberation, independency, and innovation through the ecosystem, because in order to make those advancements, a single vendor is not sufficient. You need to have an ecosystem and work together. So we will see more engagement, I guess, maybe not in 2025 because of some, macroeconomic issues going, through the world, around the world. But within 5 years, till 2030, I see more engagement and collaboration through the vendors. Maybe people in this call will work together from various and multiple disciplines for IoT, 5G, 6G, NTN. And probably we will work together more and more. So behave.
Thank you, Aaron. Dr. Mai?
Yes, in my opinion, one of the topics which will come this year is the privacy issues. So lots of technologies which are suggested for 6G, including the joint communication and sensing, and also IoT, have a real threat on our privacy. So how do we deal with these new technologies, and what's the limits of these technologies to enter our own private lives? One also big topic is trustworthiness. So it's one of the gray topics which we don't have really definitions for it. So who do we trust, and what is trustworthy, and how can we define KPIs to say, okay, I trust this network, I trust this provider, or I trust this application. So I think this is coming for 6G.
Yeah, just adding up to Erin's topic earlier about the deployment of a private network. In our industry, in the satellite network, we now before we only offer the geo satellite, right? So geo satellite is really a bit of a latency issue, right? So that's why we created, or we had launched MEO satellite, and now we are offering multi-orbit satellites. So MEO, GEO, LEO. And one of the challenges really on the private 5G is not just only the deployment. It's also about the challenges on the local what we call some kind of the government limitation deploying services on a private network. There are some sort of a legality, regulatory issues that we also have to deal with, especially say for example in the Netherlands. I think Netherlands is like one of the lowest deployment in a private 5G because of the regulatory constraints, which compares to other regions or other states in the European, in Schengen area, for example. So I think this 2025, I hope that these regulatory issues can be resolved or can be a bit lightened up a bit, because we are also providing service on main ports. Main ports are airports and seaports, and these are also. I've been in a session in Schiphol, and they have complaints about regulatories. So I hope that this 2025, this kind of less regulatory constraints will happen, so we can fully deploy at a private network, not only on a specific application, but also one each required to kind of sites that it's more about critical communication, right? How can we bridge the gap to bring the connectivity to these secured areas?
Yes, if I can add also about critical communication, in the last Olympic Games, we have tried the push to talk over 5G for the security in the Olympic Games. It was really a good experience. This is the future. The theater, yes, it was good in the last decades, but now in Western European countries, we face some. We have good innovation. I see a good presentation about AR, about metaverse, but we should put it in the real field. So it's really, if you don't trigger it, so we innovate, but we put it in the desk. So it's not really. It's not opportunity for the innovation. So we try to maybe to explain to our industrial how to put it in real time, in real field. And I think in this year 2024-25, I hope that all experts as we are, we try to help our industrial to keep the industry in Europe. Don't go to abroad to try 5G or other technologies instead.
Hayat, would you want to share anything? I think digital twin also is quite popular, is getting into trend. A lot of discussions towards to the 6G as well. Do you have anything to share?
Yes, actually, I would like to adding to all of the point of views of the other speakers. From academic perspective, I see that in the future, it's going towards AI, ML topics, and also about semantic communication, where we humanize a little bit the process of network management. The introduction of large language models is also a hot topic for the moment, and I think in 2025 it will be more and more investigated. So I agree with all of the speakers that these are the topics of interest for 2025, and yeah, that's my vision also. Thank you.
All right. So I think that's all for today. I think thank you so much for your contribution, and we will be promoting each of the speakers on our LinkedIn page and also in our newsletter for the next 1 month. So it's going to be a full sparks of promotion to the speakers today for the next 1 month. And to the audience, please do click the subscribe button on our YouTube channel. This video will be uploaded on our YouTube and will be available in the next couple of hours. I'm so grateful. Thank you so much. I really appreciate your time. Till the next time, thanks again. Thank you. Have a nice day.
Thank you.
Thank
Thank
you.
you.
Everyone.
Bye-bye.
Have a nice day.
Bye-bye. Cheers. Bye-bye.
Bye.